this video on the Comptia Network Plus course. Common Ethernet cable types. Name, speed, transmission. 10 base 5 coax, 10 megabits per second, 500 meters per segment, also called TICnet. This cable type uses vampire taps to connect devices to cable. 10 base 2 coax, 10 megabits per second, 185 meters per segment, also called ThinNet, a very popular implementation of Ethernet over coax. 10 base T UTP, 10 megabits per second, 100 meters per segment, one of the most popular network cabling schemes. 100 base T UTP, 100 megabits per second, 100 meters per segment, one of the most popular network cabling schemes. 100 base VG UTP, 100 megabits per second, 213 meters Cat5, 100 meters Cat3. 100 base T4 UTP, 100 megabits per second, 100 meters per second requires 4 pairs of Cat3, 4 or 5 UTP. 100 base TX UTP STP, 100 meters per segment, 2 pairs of category 5 UTP or type 1 STP. 10 base F fiber 10 megabits per second ranges from 500 meters. Ethernet over fiber optic implementation. A 100 base FX fiber 100 megabits 2000 meters 100 megabits per second Ethernet over fiber optic implementation. 1000 base T copper 1000 megabits per second 100 meters. 1000 base FX multimode fiber 1000 megabits per second 260 meters uses SC fiber connector. 1000 base TX gigabit Ethernet category 5 UTP 1000 megabits per second 100 meters uses same connectors as 10 base T. 1000 base LX multimode fiber 1000 megabits per second 550 meters uses longer wavelength laser than 1000 base FX FDDI multimode fiber 100 megabits per second 10 kilometers uses MIC connector. Common network connectivity devices. Now that you are familiar with the various types of network media and connections, you should learn about some devices commonly found on today's networks, because these devices connect network entities. They are known as connectivity devices. These devices include a network interface card, NIC, the hub, the switch, the bridge, the router, the gateway, other devices. NIC, the network interface card, as its name suggests, is the expansion card you install in your computer to connect or interface your computer to the network. This device provides the physical, electrical, and electronic connections on the network media. Network interface cards are either an expansion card, the most popular implementation, are built into the motherboard of the computer. In most cases, a network interface card connects to the computer through expansion slots. An expansion slot connects expansion cards that are plugged into a slot in the main computer assembly through a decisively simply looking connector, which is known as a bus. In some notebook computers, NIC adapters can be connected to the printer port or through a PC card slot. Hub, as you learned earlier in a star topology Ethernet network, a hub is the device that connects all the segments of that network together. Every device in the network connects directly to the hub through a single cable. Any transmission received on one port will be rebroadcast to all the other ports in the hub. So if one station sends it, all the others receive it, but only the intended recipient listens to it. Switch. Like a hub, a switch connects multiple segments of a network together with one important difference. Whereas a hub broadcasts anything it receives on one port to all the other ports, a switch makes a direct link between the transmitting device and the receiving device. Any party not involved in that communication will not receive that transmission. Benefit of a switch over hub is that the switch increases performance because it doesn't suffer from wasted bandwidth of extra transmissions. A bridge. A bridge is a network device that connects two similar network segments together. The primary function of a bridge is to keep traffic separated on both sides of the bridge. Traffic is allowed to pass through the bridge only if the transmission is intended for a station on the opposite side. The main reason for putting a bridge in a network is to connect two segments together or to divide a busy network into two segments. A router is a network device that connects multiple, often dissimilar, network segments into an internetwork. The router, once connected, can make intelligent decisions about how best to get network data to its destination based on network performance data that it gathers from the network itself. Gateways. A gateway is any hardware and software combination that connects dissimilar network environments. Gateways are the most complex of network devices because they perform translation at multiple layers of the OSI model. For example, a gateway is the device that connects a LAN environment to a mainframe environment. The two environments are completely different. LAN environments use distributed processing, baseband communications, and the ASCII character set. Mainframe environments use centralized processing, broadband and baseband communications, and EBCDIC character set. Each of the LAN protocols is translated to its mainframe counterpart by the gateway software. Another popular example is the email gateway. Most LAN-based email software such as Novell's GroupWise and Microsoft's Exchange can't communicate directly with Internet mail servers without the use of a gateway. The gateway translates LAN-based mail messages into the SMTP format that Internet mail uses. Other devices. In addition to these network connectivity devices, there are several devices that, while may be not directly connected to a network, participate in moving network data. Some of these devices include modems, ISDN, terminal adapters, CSUs, and DSUs. A modem is a device that changes digital data into an analog form for transmission over an analog medium and then back to digital again at the receiving end. The term modem is actually an acronym that stands for modulator demodulator. When we hear the term modem, three different types should come to mind: traditional POTS, DSL, and cable. Traditional POTS. Most modems you find in computers today fall into the category of traditional modems. These modems convert the signals from your computer into signals that travel over the plain old telephone service POTS lines. The majority of modems that exist today are POTS modems, mainly because PC manufacturers include one with a computer. DSL digital subscriber line is quickly replacing traditional modem access because it offers higher data rates for a reasonable cost. In addition, you can make regular phone calls while online. DSL uses higher frequencies above 3200 MHz than regular voice phone calls use, which provides greater bandwidth up to several megabits per second than regular POTS modems. DSL modems are the devices that allow the network signals to pass over the phone lines at these higher frequencies. Most often, when you sign up for a DSL service, the company you sign up with will send you a DSL modem for free or for very low cost. This modem is usually an external modem, although internal DSL modems are available, and it usually has both a phone line and an Ethernet connection. You must connect the phone line to the wall and the external connection to your computer. You must have an Ethernet network interface card in your computer in order to connect to the DSL modem. Cable. Another high-speed internet access technology that is seeing widespread use is the cable modem access. Cable modems connect an individual PC or network to the internet using your cable television cable. The cable TV companies use their existing cable infrastructure to deliver data services on unused frequency bands. The cable modem itself is a fairly simple device. It has a standard coax connector on the back as well as an Ethernet port. You can connect one PC to the cable modem. The PC will need to have an Ethernet network interface card installed, or you can connect the modem to multiple PCs on a network using a hub or switch. ISDN terminal adapters. Integrated Service Digital Network (ISDN) is another form of high-speed internet access. It delivers digital services in 64 kilobyte channels over standard telephone copper pairs. The device you must hook up to your computer to access ISDN services is properly known as an ISDN terminal adapter. It's not a modem in the truest sense of the word because the modems change from digital to analog transmission, but an ISDN terminal adapter isn't changing from digital to analog, it's changing between digital transmission formats. The box itself is about the size of a modem and looks similar to one, but like DSL modems, there is a phone jack and an Ethernet jack. You can connect a phone cord from the phone jack to the wall jack where your ISDN services are being delivered. Then you connect an Ethernet cable from your PC to the ISDN's terminal adapter's Ethernet jack. Channel Service Unit Data Service Unit. The Channel Service Unit Data Service Unit is a common device found in equipment rooms when the network is connected via a T-series connection, i.e. a T1. It is essentially two devices in one that are used to connect to a digital carrier. The T uses our DSL line to your network equipment, usually a router. The Channel Service Unit (CSU) terminates the line at the customer's premises. It also provides diagnostics and remote testing. If necessary, the Data Service Unit (DSU) both does the actual transmission of the signal through the CSU. It can also provide buffering and data flow. Both components are required if you are going to connect to a digital transmission medium such as a T1 line. Sometimes, however, both of these components may be built into a router. If both components are built into a router, you only have to plug the T1 line directly into the router. Summary. In this chapter, you learned about the items that can be found on a typical network. You first learned what a network is and the various elements that make up a network, such as servers, workstations, and hosts. Then you learned about the different ways of laying out a network. You learned about bus, star, ring, mesh, hybrid, and wireless topologies. You also learned about the different types of physical media in use on networks today, including coaxial, twisted pair, and fiber optic media. Finally, you learned about some common network devices, including network interface cards, hubs, switches, bridges, routers, and gateway seen on a typical network. So I'm going to leave it here today for this video. If you liked listening, please consider like, sharing, and subscribing. And thank you again.